Magnets, crystals, pyramid. Magnets, crystals, pyramid. Welcome home, family, and join us for the fun. Colorful guests, people everywhere under the sun. Interesting conversations. Prayers first has begun. Invocation, manifestation, conversation, then will come. Magnets, crystals, pyramids. Magnets, crystals, pyramids. Magnets, crystals, pyramids. Magnets, crystals, pyramid. Let's start drinking some water, juice or tea. King Killer's recommended for you and me. Guayusa mixed together, maple syrup or honey. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Learn from the healers, crystals, pyramids. Learn from the healers, the artists, the seers, authors and teachers, dissolving your fears. Workshops of wisdom, the circle is wide. Plant medicine whispers, the planets align. No magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Crystals and pyramids, magnets that spin. Organ awakening the power within. Tantra and herbs, the gateways ignite. Shamanic drums calling truth into light. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Psychedelics painting vision so bright. Planetary activists guarding the night. Awareness expanding the cosmos in view. Higher vibrations are flowing through you. Magnets, crystals, pyramids. Hey. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Xenon and herbs, you'll feel much better. Drink your tea now instead of later. Stay ahead of your health. Health is always your greatest wealth. Oh, no, no. Magnets, crystals, pyramids. Hey. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Mad science fun, Talib bless. Experiments under the sun. Sacred fire, prayers begun. Success and happiness, your destiny has come. Magnets, crystals, pyramids. Yeah, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Learn from the healers, the artists, the seers, authors and teachers, dissolving your fears. Workshops of wisdom, the circle is wide. Plant medicine whispers, the planets align. No magnets, crystals, pyramids. Yeah, magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Oh, crystals and pyramids, magnets that spin. Organ awakening the power within. Tantra and herbs, the gateways ignite. Shamanic drums calling truth into light. Magnets, crystals, pyramids. Oh, magnets, crystals, pyramids. Magnets, crystals, pyramids. Magnets, crystals, pyramids.
Welcome everyone. Welcome to Moorish Monday on Magnus Crystal's Pyramid. YouTube, and Moroccan Post Media YouTube. Welcome. We have a wonderful show prepared for you tonight as we wait for Brother El Kanah Bey to appear. Brother Hank, is he backstage? He said he's backstage. Give him a call, Israel.
All right.
Yeah, he said he was backstage. The explanation of the astronomical origins and the Masonic correlation as it relates to Christmas. He's not backstage. All right. Welcome, everyone. Let people know that we're live and direct. Share this to your various social media pages. Hit that subscribe button if you haven't done so. If you like the show, hit that like button. Across the screen, strolling across the screen is my website, mooresandmasonry.org. For my books, Moors and Masonry Part 1, Moors and Masonry Part 2, How a Venus and Moon Rule, Etymology Vocabulary, Etymology Vocabulary Supplementary 1, the Masonic Company Square and the Connection to Measurement and Timekeeping. Go to mooresandmasonry.org. Those who are joining us, once again, we have the explanation of the astronomical origins and the Masonic correlation as it relates to Christmas. We're waiting for Brother El Kanah to join us. Seems to have some technical difficulties. Is he? What's going on, Israel?
No answer.
But call him again. I mean, I just got off the phone with him.
Yeah, I know.
And he said he was backstage. He said he was already on.
I sent him the StreamYard link again. So
yeah.
Try it again.
Yes. Yeah, he said he was backstage. So all right. So welcome once again to Moorish Monday with Abdullah today, Mosi Bey. We're waiting for our guests to come on. I thank you all for your support. I'm in my third year now. I always give great honors to Uncle Hank for offering the platform to me 2 years ago. He was able to. I don't know what's going on. Welcome. Well, we had the winter solstice. Happy winter solstice, everyone. Happy winter solstice. The sun died, the lowest point of declination. And
okay. He said he's in there now.
He's backstage, Hank. You see him? Yeah. He doesn't see him. The same thing's occurring. Wow. Tell me he got to do the phone thing, man. Yeah, we got to do the phone thing. Oh, there he is. We can't hear. Can't hear. Can't hear.
He said he's not muted.
I'm not muted.
Oh, we can hear you now.
No, hold on.
We can hear you now.
That's because he's on my phone. Hold on, say it again. Can't hear him, huh?
No.
We can't hear you. We can't hear you on there, bro.
You're not muted, but we can't hear you. What's, he's not muted because I don't see, but you check your settings or something. Your volume. Can't hear you. Ah, man. All right. Yes, as I said before, the sun. Welcome. I have a happy winter solstice. That is an astronomical phenomenon. There's 2 points where the sun's out of outer limits that our ancestors charted thousands of years ago. Now, hey, Brother Hank, what do you think the problem could be? Is it in the settings somewhere? Wow. So we got the video, but we don't have the audio. His settings. Go to your settings. Your settings. Go to your settings. You tell me you guys go to his settings, Ezra. Quick, give him a call. Let's go to his settings.
Yeah, I'm still on the phone with him. I'm trying to get him through now.
All right, good. All right, so you have the extreme northerly point and the extreme southerly point. And those are known as the starstidial points. The extreme path of the sun, the northerly path of the sun, and the extreme southerly path, or the extreme southerly path of the sun. Those are known as the starstidial points. And our ancestors charted them thousands of years ago. So Kanah, as he will give the explanation of what Christmas is astronomically. How is that determined? How is the birth of the Son, baby Jesus, the resurrection, which is not Easter. Easter is not the resurrection. Easter is Venus, so Easter is not the sun. Easter is not Jesus. Jesus is the actual sun. Easter is Venus. That's Astarte, Ishtar. And so this is as we wait for Kanah to get the sound. We continue to so I don't want to give everything away. We have January 1st is coming up. And I don't know if that's part of Kanah's presentation. So I'm trying to say as less as possible. January 1st is January 1st, the new year. How is the new year determined? How is that? I mean, when it says the new year, how is that? What knowledge base is used to determine the new year or a new year? How is that measured? What constitutes a new year?
He said, "What if he does it through my phone? I guess like he did it last
All right,
time."
yeah, but you have to do that then. Yes. All right. So we can get going. All right.
All right, let me back up here. Damn, did it knock me out?
Yeah.
Hey, can we keep his audio up or no? And see, we can have the audio up, right? I mean, his video. I'm sorry, his video. He's gone. What? Yeah, what happened? He's got
Yeah,
knocked out.
I think he knocked himself out. Yeah.
Hold on. Abdullah.
Yeah, you're good with the sound. The phone through the phone.
I don't know why that's acting like that though.
All right, so yeah, I'm trying to say as less as possible because I don't know what you have in your presentation. So just think on what constitutes the new year. How's that determined? Is January 1st a new year? March 21st, July 4th.
I did that. I did it, and I went to speakerphone. Speakerphone is not working. It doesn't seem like it.
All right, so you're on we can hear you. So we about to get started. How we go?
Yeah. Let me come up with this.
Yeah, we got to work on this computer thing, man, with you, brother. Your cousin laptop, but you ain't got your cousin's laptop, so. All right, so let's get cracking.
Yeah. All right. In the studio. I'm backstage again now.
He's backstage, Hank.
Hey, this technology, I don't like.
You got to, you just got to do better, brother. No problem.
Yeah. Just gotta.
You see him, Hank? He's backstage. We can get his video up. We want it. All right, let's get started, man. Come on, let's get started.
All right. So you got me in there, right?
Yep.
Yeah, we good. Let's get started.
All right. Come on, let's go.
The screen needs to be shared.
We got a screen. Share the screen. Let's get started. That's all. Don't worry about that. Let's get started. So share the screen. Once the screen goes up, we're gonna get started.
Yeah, Hank has to pull it up.
Brother Hank. All right. Because he's wait. All right, thank you, Brother Hank. Uncle Hank. All right. You have the floor.
All right. Good evening and welcome to another Moorish Monday, 4th Monday of month. What we're taking a look at today is the explanation of the astronomical origins and the Masonic connection, relation as it relates Christians. All right, let's go to the next slide. Now, what we're looking at here, as we go through from northeast to northwest, and we look at from June to December, we look at us being more likely as we are approaching the summer months, April, May, June, July, August. And as we start going towards the fall into winter, then we're looking at the sun decreasing. So in this particular graph here, we do kind of see a figure 8, but a better explanation of it here on the right side, we're looking at the sun as in the summer months, it is at its highest point of inclination. Then as we get to the winter months, or fall to winter, we start seeing a declination of the sun. All right. So let's go ahead and move to the next slide. All right. This is more of a closer, definitive explanation of what we just saw from the previous slide. More specifically, when we look at December the 22nd, the 23rd, and the 24th, remember, we're coming from the sun being at its highest point of inclination. So, as we look at the first slide, or first picture rather, on the top left corner, we're looking at a night sky. All right, depending on where you're looking at it from. All right, so we're looking at this particular point, December the 22nd, 23rd, and the 24th, is the sun in a apparent death. So it appears that the sun has died, the S-U-N. Where we get the idea of the son of man or Christ dying, it comes from this concept throughout all of the cultures, ancient cultures. And we're looking at the depths of the sun. Now, let's go below that picture. On December the 25th, the sun now, its arrows is going up. Technically, this first picture above it, there shouldn't have been a sight of the sun, because the sun is in apparent death, you can see the sun during that time. But December the 25th is when the sun just starts to be visible. It starts rising. So we look in masonry, we say we're looking for more light. The more light is the sun, after it being dead or apparent death, it's now rising and it's gaining more light. We're seeing that we're getting more light. And as we move from December the 25th to June the 21st, this is us getting more light. All right. Now, when we look at the right side, of these 4 pictures right here. So we have the left side where the appearing death of the sun, and then the resurrection of the sun. That's Christ's resurrection. That's the sun, S-U-N, coming up, and that is the S-O-N coming up. It's a resurrection. Okay? So now we look on the right side, top right, and what we have here is Orion. The picture's not showing Orion, but what it's showing is the name 3 Kings. The 3 Kings are a star constellation, and they are representing Orion's belt. So, with Orion's belt, you see the brightest star in the constellation, Sirius. And that is known as Kanah Major. The mythological story is Orion had as the husband, he had 2 dogs. Kanah Major.
Look into the camera.
Oh, I'm sorry. I didn't pick it up. Kanah Major and Kanah Minor. We're not looking at that minor right now, but we're looking at Kanah Major, the dog star, Sirius, or in the lodge we call it the blazing star. Okay, so here is the sun in the corner. It's the birth of God's S-O-N and God's S-U-N. At the winter solstice, there are 2 points. You have the northern point or the custodial point of the summer solstice, and then you have the southern point, which is the winter solstice. Okay, so here what we're taking a look at is a resurrection or a birth on December the 25th. That's where we get the idea, or we get the statement of December the 25th is Christ's birthday, because it's the resurrection or the birth of the Son. It's human, and it's used as the birth of the. It's used as the birth of S-O-N, but it's the birth, the actual birth of human. Okay, and again, this is the winter solstice. Okay, coming out of the winter solstice. All right. Now below that, we have the Southern Cross or the Celestial Cross. And what happens here, again, is we're dealing with the sun, of course. But what we're looking at is 4 seasons. And the 4 seasons we obviously are looking at is, and going back to the solstice, we have the summer, which, if you look at this picture that has Sirius, birth of God's Son, imagine the sun above Sirius. So we see Sirius shining bright. So just say if that sun was above Sirius, and then we look straight below, we're looking at the two solstices. And I'll come back to that because it's going to be hard to imagine that without the picture. Some people follow along with it, but that's not going to be a clear vision of it. We'll come back to that. But I'll just talk about the three kings briefly. Again, Orion's belt. When you look down from Orion's belt, he has what's called a stagboard. And what that is a sword. It's like a pocket case for the sword. It's just something that can shield the sword when the sword is put up. So that's how you be able to find Sirius if you identify the three kings, which are the three stars that are in alignment on Orion's belt. So let's go. We'll move to the next picture and slide and see if we can get a little more about how the sun is moving. All right. So in this particular picture, we're looking at 2 points on the outside of the circle, forming an arc. There's a circle, and then there's a midpoint in the center. All right. So it's a perfect alignment in forming a right angle. There are 4 right angles that are formed. There is the summer solstice, the sunrise, as we see, and then there's the winter solstice below it. Now, what we have, the point in the middle of that circle is the spring equinox. And if we drew another circle, the midpoint of that circle would be the fall equinox. So before we saw a galactic cross, we saw a cross in the last slide. This now is talking about the equinox. So you have the summer solstice, you have the fall, the winter, the summer and the winter solstice. Okay, that's 2. That's forming the upright or the vertical line for the cross. We're talking about the cross now. And then if you take a look at this point in the center of this circle, that talks about the spring equinox. And if we had another circle, equal distance, and we put when we look at the midpoint, then that would be the fall equinox. So now what you're looking at is 4 points. And in those 4 points, you draw a vertical line from the summer to winter solstice, and then from the spring to the fall equinox. And what you're looking at is the black circle, which is talking about the 4 seasons. Okay. So I'm going to read the caption up here. If you know the position of the winter and summer solstice, which are the 2 points that we have outside the circle, okay, the 3 states, the central state, and the 2 solstice states can be used to determine the position of the true east. As you see with that circle, and you see an arrowhead, which is pointing to the midpoint which is the spring equinox. Opposite of that would be true east in the diagram as we see that. Right. All right. Now, going over the next picture to the right, look at this. We see a circle that's drawn on the ground. All right. And then we're going to say that this is, let's look at it this way. Do we see how much the above end look like a threshing floor? All right. If you were using threshing floor as a solar observatory, and if you mark the salt point with 2 sticks, your threshing floor would look like this. Now, there are 2 points, the stakes that we see. Just like the picture we just took a look at, we look at the stake in the middle, in the center of the circle. All right. And then we take a look at the top stake, which would be the summer solstice. And then we look at the bottom stake, which would be the winter solstice. All right. And then opposite of that middle stake, coming out of that circle, would be due east or true east. Okay. All right. So a lot of pictures help us to kind of understand the concept. I want to make sure we get the concept. All right. So let's go ahead to the next slide. All right. And again, here what we'll take a look at is the winter, or let's say summer and winter solstice. All right. And I'll read this here. In Freemasonry, the symbol of 2 parallel lines, a point within the circle, represents the concept of a Mason thing within the boundaries of morality and virtue, with the point representing individual Mason. Okay? Individual point in the middle. And the circle representing the limit that we don't cross. We don't go outside that point. Right? While the parallel line symbolize the patron saint of Freemasonry. And then you ask who patron saints? St. John the Baptist and St. John the Evangelist, essentially signifying that by adhering to the teachings of Masons in that era. Okay. So that within itself is a major point. That's a major point. Right? So let's go ahead and let's move on to the next slide. All right. The mass. It sounds like mass, but math. Math. All right. So the local vertical line is shown by the arrowhead. So you have a line with the arrowhead. Okay. And then we have a dark line, bold line. All right. And we have theta. And theta is representing a 90-degree angle. Now, we also have, well, first of all, that's the angle that's being formed. But then now there's a triangle. Think of this as those timers, those cooking timers. That triangle that you see is standing up. It is formed at the central angle, a right angle. It's at the midpoint of that circle, which is the middle. It's a 30-degree angle. And the bold line pointing towards the sun, and that perforated line going down to the 90 degrees, that's a 60. So you have a 60, 90, 30-degree right triangle. All right. Again, this now is still blocking time and looking at the light that we have as we're going from summer solstice to winter solstice. Okay. So let's take a look on the other side here. So we look at the sun at a maximum height. Let me just enlarge. All right. So we take a look at the sun to our far left, and we see it's at a higher it's here right over at, what does that say? Katia. Yeah, that is the higher of the three degrees of the sun. And I'm trying to enlarge this a little bit. I think that's 32.4. All right. Yeah. That's good. That's better. Yeah, that's way it is. Yeah, that's good. Yeah. So the sun at the maximum height at the lowest point of declination is December the 21st. That's the winter solstice. That's the extreme lowest that the sun is going to be at. It's a apparent depth. It's at its lowest point. At its highest point, the maximum height, and we're looking at the degrees down here, so I'm going to get back to that. But at the highest point of inclination, it is June the 21st. And that's the summer solstice. So here we're representing the summer solstice in blue and the winter solstice in red. And we have the dates for the winter solstice, December 21st, and the date for the summer solstice, which is June the 21st. We see 32.4 degrees, and that's where the sun is not at its highest, but we're looking at the angle that's being formed. All right. This is in the central angle at the bottom. You see it's 77.4 degrees. You see a line going from the base up to this next segment or line segment, then that's 30.4 degrees. All right. And it's at its higher point here. But now when we move to relative, the circle, the triangle in the middle. You have the central angle now moving over to, it's moving from the 90 degree and it's moving to 71.3 degrees. This next line segment, and you see like a little bit of an arc where it's going to fade, all right, to the line segment forming the degree 26.3 degrees. All right, so that's what the numbers are, just to explain what the numbers are. And then the final one is you have 66 degrees, and then the arc here, or the measurement of the angle here, smaller angle, is 21 degrees in Ricardo. Right? So that is those are the pictures when they're talking about how the sun is going down each day, or going by, weeks or month. The sun is, we're losing light, right? It's just another way of explaining it. So we've had 3 different examples, and some are more technical than others, but we're showing several different ways of seeing how we're gaining more light and we're losing, light, right? So just different examples. All right, let's go on to the next example. The next slide. All right. So here, what we're taking a look at noon, right? Time the sun is due south of the position of whatever particular position you're at. So if you're aligned the hour hand with the sun, and the 12 o'clock position is south. So both you have the minute hand and you have the hour hand, right? So the 12 o'clock position is south. And again, we look at that, it's south, north, right? And then we have east and west. Or in this case, 9 will be your, So if we're looking at it that way, we look at south, north, or if we look at 6 o'clock north, then we look at 12 o'clock and south. Then we look at true east would be 3 o'clock, and then west would be 9 o'clock. Again, we only have these 4 numbers because, again, we're representing a clock or showing a clock, and we have the sun because we're looking at the sun at its highest inclination. We're looking at the summer solstice. And then as we go from 12 to 3, we're looking at the fall equinox. 3 to 6, we're looking at the winter solstice. And then from 6 to 9, we're looking at spring equinox. Okay, so just by using this clock here and this circle, we can look at the summer solstice, the winter solstice, the spring equinox, and then the fall equinox. That brings us to the fall seasons. Okay. All right. This next picture here, we're taking a look at 3 orbits of the sun. So the previous picture helps us to understand this picture here. Now, the sun that we see at the top is not at the highest point of inclination, but it's still the summer solstice. When we take a look at the lowest picture of the sun, we're looking at winter solstice. And then it's kind of hard to see in this particular picture, but what we take a look at is the middle sun is representing the equinox. Okay. So seasonal new sun angle for a given north latitude. All right. So I'm going to read here. The Earth's tilt relative to its plane of orbit. And again, this really depends on where you're standing, how you can actually take a look at the angle from the orbit, right? And then looking at the plane of orbit and then looking at the sun. So latitude of, and it's just this example here, latitude of where this person is at, southeast Michigan is 42 degrees. Therefore, the equinox angle is 90 degrees minus the 42.48, which equals 47.12. So the summer solstice noon, where this person's position is 47 degrees and 12 plus 23 degrees and 28, which equals 70 and 48. Likewise with the winter solstice. So the point was, take a look at 90 degrees, you see that none of these angles are at 90 degrees. But when you take a look at the 90 degree, and you look at the measurement from the orbital plane and the sun, you look at plus 23 degrees. And that's summer solstice at noon. Then we take a look at the 93 minus, when we look at the winter solstice, it's minus 23 degrees. Okay? So this is 90 degrees north latitude. Knowing your position and knowing where the sun is, there are tools you can measure in order to find what the angle is. And the angle would be, if you're looking at an equinox and you're looking at the position of the summer solstice, then you can figure out the degree. And once you do that, that's how you come over here and start looking at the calculation. So the equinox noon angle is 90 degrees. All right, as we see that in the picture. But now, if we track 42 degrees and like 48, when we do that, we come up with 47 and 12. When we look at the summer solstice at noon, we needed to find out the equinox at noon in order for us to be able to determine the summer and the winter solstice. Because once we have that 47 and 12, it becomes easy because when it's the summer solstice, you add 23 degrees and 28, right? So that gives it 70 degrees, 48. But then you have the winter solstice at noon, which is 47:12, same number, right? Minus 23, 28. So that number doesn't change except for the plus or minus. All right. So that's a bit of the math involved.
Yeah, that's good, brother. That's oh man, that's good. Thank you, man.
Yeah.
I told him 7 years ago he'd be able to do this better than I can.
Say that again.
I told you, I say, I'm telling the audience, I told him 7 years ago that he will be able to break this down better than I have.
Yeah, but you know what? we're gonna have a conversation after this stuff. So anyways, is this picture come up, the one at the bottom that got the gold and the yellow? Oh yeah. I was about to say, I said, man, it's amazing right here. What this is talking about is the Earth's tilt. Now, let me go back up here real quick. Two things I want you to take a look at. The angle from that square, that white square at the bottom, and we take a look, that equation that we did, that was important because why are we looking at 23 degrees or 23.5 degrees? The Earth is on a wobble or tilt. So in order to understand or find the solstice, the degree from the position of where you are in the orbital plane, we gotta take in consideration the wobble. And because we're going towards the winter solstice, we're subtracting 23.5, which is the wobble. And in the summer solstice, we have to add 23.5. So as you see in this equation here, once we took a look at the equinox, and we took a look at 90 degrees, we had to go with 42 degrees and 48, and we needed to subtract that angle from the 90 degree in order for us to get to our starting point. So our starting point for the summer solstice and the winter solstice, we both have the same degree. The issue is, if we're looking at the summer solstice, we're looking at more, we have to add that wobble, the 23.5. But at the winter solstice, we have to subtract. All right. So looking at the north and south, this longitude dial is at a 23.5 degrees. So that's what we're actually looking at. That's that tilt. That's the Earth's tilt. It's not a true north. It's more like a northeast. Now, this is resonating for Masons on the line. When all of this means something. Remember, we're taking a look at the astronomical values we're looking at the astronomical values. So we look at 23.5 degrees, and we're looking at the north. That's not a true north at 90 degrees. So we're looking at that northeast corner. All right. And then we have the southwest corner. So that's talking about the waffle, but then it has other meanings in the lodge when you're talking about east corner. Okay. Taking a look at something here too. You look at the sun. You look at the orbital plane. All right, that's in the middle. And somebody has something on the background. You cut it off. So in the northeast corner, looking at that particular degree, we're looking at 42.5 degrees north. And then you look at the equator here. Again, you still see the Earth wobble. So, you know. But these are short points, but at least here's the visual, and I'm giving the explanation of these short points. You know, we don't need to turn it into a whole book or whatever. It's an actual point, but we just want to be able to take a look at this. All right, let's go ahead and let's move on to the next slide. All right, and again, hopefully I'm the dead horse, because I want to make sure that the point is being made. The two solar pillars of Boaz and Jotham, or Jashin, points within a circle, lane of the cornerstone, and the key, or we say keystone, and St. John's Day. These are the astronomical markers for the summer solstice and the winter solstice. So the sun's position during the summer solstice and the winter solstice is as follows. All right. Looking on the plane of the horizon, looking, you know, from the top down, you have, and I don't really like this picture 100%. Realistically, well, I'm doing two different explanations here. I'm going to explain this chart or diagram, and then I'm going to give you some more explanation. So we see the summer solstice, that's just at its highest point, and the winter solstice is at its lowest point, and then we have spring and autumn or fall equinoxes. All right, so let's talk about what that really is. The observer is the person that's in the middle. Okay, we look at this as a mason in the middle, and then here are our two lines, this circle, right? Okay, so you have the south, which is the summer solstice, the north, which is the winter solstice. You have the east, which is the autumn equinox, and you have the west, which is the spring equinox. I'm gonna have to change this bottom here so that it becomes, you know, typically clear. And what this picture is showing is that the sun is dropping down, or it we're losing light. Or look at it from reverse, we're gaining more light. If we go from the winter solstice to the summer solstice. But again, this is dividing, and there's like a great circle in the sky. And it's, you have your, what do you call it? Galactic cross. That's dividing the things. Okay. So this is the horizon again, and then that's the observer. So it's two different things being shown at one time. But it'd be better just to understand.
Kanah, so start this. So that where we are right now is the winter solstice. So that's where we are right now. So we're regaining more light.
We're gaining more light.
We're gaining more light. So the sun died. Yeah, the sun died yesterday. Jesus died on the cross yesterday. The sun died. So now we'll be gaining more light. So we're gonna start. The orientation would be the winter solstice, moving it, go ahead into the spring. You know, Lent. So the Lent starts. The Lent starts because Lenten days are lengthening. So the resurrection begins. Lent begins. Days begin to lengthen. The resurrection begins. And I said to them while you were getting ready that Easter is not the resurrection.
No.
That Easter is not the resurrection. When you're talking about the winter solstice, the vernal equinox, but the resurrection is now.
The resurrection is now.
And Elkanah explaining astronomically. He's explaining astronomically and mathematically the Lenten and the resurrection. That's the giving the astronomic. So he's doing a good job. Just wanted to add the Lent in and the resurrection in, tying it to what you're explaining now. Because there's been misorientation about Lent and the resurrection. So you're setting this record straight with the astronomy and the math.
Indeed. Thank you, brother. That's good. That was good point. Talking about that. But that's a direct tie. The Lent is talking about Lent, right? It's talking about the Lent, Lentgh, the Lent, talking about the Lent, right? That says the days are getting now longer. They're getting longer now, more light. Okay. Let us go to the next slide. All right. So we got a couple things going on here. Let's start from the outside, work our way inside. Well, we have a line that's going through circle. And this circle is Earth. Okay? We have on the outside, we take a look at the zenith. That's looking at our due north. Looking at this from, so this is a two-dimensional because it's a flat circle. But this really, we know the Earth is round and it's a sphere, right? So that's what this equator is doing. You see 2 circles, right? You see 3 circles. Let's talk about that. Okay. So that green spot is the core. Now we have a person standing inside the core, and this don't have no type of meaning to it. This is just if you were standing on the ground and you're looking up, right? So that's just what that is. But that circle inside the larger circle, just imagine that as a sphere. And this is the equator that's below, or that's the middle circle. All right. And it gives the direction north, the south, and then east to west. All right. So the 23.5 degree is the wobble. And that's why you see this line, and it not at the true, you know, it's not 90 degrees. You know, it's not horizontal or vertical the plane, right? So that's what the wobble is. And we take a look at June solstice, which is, of course, the summer solstice. And we look at the December solstice, which is the winter solstice, right? For June 21st, and then we have December 21st. Now we look at March, which is the spring, right? Or winter. And then we look at September, which is the autumn or summer. So you got March, September, we have June, and December. There again, there's the 4th season. There's the wobble at 23.5 degrees. Okay. And that talks about this again. This the person that's in the core, if you want to call it. It is the core, the middle of the earth. This person is literally just standing on a surface, right? They're standing on the surface. The only reason why they have this circle in there is because it's talking about the equator. All right. And we have this person that's in there, and they're just looking up and seeing how, you know, the sun is moving, you know, from summer to winter. Okay. So let's go ahead. And that's really our purpose, so that we can understand, again, the direction of the sun and what's going on, and then influence the equator. All right. So let's move on to the next slide. All right. Much more to say. All right. So we have the North Celestial Pole, and we have the South Celestial Pole. All right. And in the middle here, we have the celestial equator, which is in the middle here. All right. So here's the Earth in the middle, and we're looking at how we are increasing and decreasing in degrees, not temperature degrees, but just angle. All right. So plus 60, plus 40, plus 30. All right. And when we get here to 0 degrees, minus 30, and minus 60 below the equator. All right. So in the zenith is up. If we could turn this, look at the light blue, then we're looking at this due north, we're looking at the Earth again. All right. And the equator is the black line that's going around the Earth. All right. So we get a better look here. So here we're looking at, and this works out a lot better. Okay. So again, we have this person here. This is you or me or anyone else that's looking. The purpose of this here is so that if you're watching from not an observatory, but just you could be watching at your backyard or something like that. You know, you have your telescope, you have other tools or whatever the case is. You want to be able to identify the degrees or find the measurement of the degrees from the position that you're at. So north celestial pole and the south celestial pole, we know that there's a wobble of 23.5 degrees. All right. So looking at we're here now in December, and we're looking at from the wobble in the north celestial pole, we're looking at from north plus 60, plus 40, plus 30 degrees. All right. And we can see that because we have it from looking at 90 degrees, and then after that, we go 60 degrees, 30 degrees, and 0 degrees. We're looking at an angle from where this person is standing. All right. So when we start looking at south, then we're looking at 0 degrees, minus 30 degrees, minus 60 degrees. As we're looking at the south of, who from the southern point or southern angle, and then from the north, we're looking at increase. So again, it's still the sun. We're looking at increasing and decreasing. More light as we're going towards the summer solstice, and then less light as we're going to the winter solstice. Just want to bring out more examples in order to get the concept. All right. Let us move to the next slide. All right. Now, all right, so we're just doing it this way. On our right, we see the picture. You see the Earth's wobble at 23 degrees. That's, or call it the tilt. Okay. You see the orbital plane. That's the perforated line going across. Then we see the equator, the blue line. Then we see the Earth's axis. Right? So when we look at this beige picture or beige dot, all right, this is you. like on a map or something like that, say, well, this is where you are, or you're here. So this is the normal circle. So we look at what's now called, well, first of all, we have a 90-degree angle, or the horizon. This is, if we look at this circle, the blue circle, as the Earth, and then we look at the line that's on this particular circle, we see a 90-degree, or we can form a 90-degree angle, right? From the surface and the horizon, we can form a 90-degree angle. So now we have called solar Venus angle. All right. Just while we're looking at this right here, I want to go over to these key points so we can take a look at the math that's being done. All right. So Earth's tilt, the Earth's axle tilt is represented by the angle, which is approximately 23.5 degrees. Now, latitude, the geographic latitude on Earth is denoted by psi. All right. Then we have the declination, the sun's declination, which is angular position north or south of the celestial equator, and it's equal to either adding, like we saw earlier, calculations. When it's the summer solstice, you're adding 25 degrees, right? Or if it's at the winter solstice, you're looking at subtracting 23.5 degrees. All right. So what I want to do is looking at this sun ray, going back to that. We have the solar zenith angle and the solar altitude angle, and that makes up the 90 degrees. And one of the reasons why I want to take a look at 90 degrees is because you're standing at a particular point. You're standing at a particular point, and it's going to form a 90-degree angle. From the plane of the surface that you're at, looking directly up in the sky high, you have your two telescopes. But what you want to be able to do is also you're looking at the Earth as well. When you look at the Earth's axis, you look at the equator, you're forming another 90 degrees. However, you have to look at the orbital plane. Well, if we looked at it from that standpoint, the equator and the Earth axis is 90 degrees. We include the orbital plane, and it's like 123 degrees. But again, this is trying to identify the degree of the angle that you're looking at when you talk about the summer solstice or the winter solstice. All right. And I'm trying to look hard at it. Can you widen that a little bit? I want to see what our solar altitude angle is. Okay. All right. Yeah. All right. Good. So for the zenith, we're looking at 42 degrees plus 23 degrees, which equals 65 degrees. Once you find the solar zenith angle, then you take that, subtract it from 90 degrees in order to get the solar altitude angle. Again, with the Moorish travel, they had to use tools and they had to use equations in order to find where they were. So when you take a look at the travel and look at stars and map making and telling time and clocks, all of this had to do with the astronomy, and it had to deal with calculation. So that's why we're dealing with this. This is our culture. We're looking at our culture and we're trying to figure out, or not figure out, but we're learning and getting understanding of how we as Moors navigate and told time and knew when to plant.
Once again, y'all, I told him 7 years ago. He didn't believe me. That he'll be able to present it better than I can. Because he has his math background. This is how you present it.
All right. Let's move to the next slide. We got. You know what? I'm just tripped out. I'm looking at a clock, and I said, "Oh, that clock has something to do with what we're doing." So, yeah, okay. So we're gonna move with a little piece here. Mathematical calculation simplified. All right. Again, I know we've only spent this time dealing with the summer solstice and the winter solstice, the vernal equinox and the autumnal equinox. But I just wanted to bring this point home in all different areas, mathematically and astronomically. All right. So the sun's altitude at noon or on solstice, to calculate the maximum sun altitude at noon on the summer solstice in the northern hemisphere, use this formula. To find the altitude is equal to 90 degrees minus your latitude plus the Earth's tilt, which is 23.5 degrees, daylight time hour. So the length of the daylight hour can be estimated using trigonometric function based on the sun's angle at sunrise and sunset, which are determined by the Earth's rotation and tilt. All right, let's move to the next one. Next slide, brother. All right. All right, so this is a chart telling when we're getting more sun, when the sunrise happens, at what time and where in the month does the sun rise and set. All right. So this is the sunrise and the sunset chart. Okay. So we're in 2025 now, but let's just, we're going to deal with 2024. That's the chart that we have. Next time I present this, it'll be 2026. But the concept is what I want to get. So the sunrise on December the 1st, do me a favor, widen this up a little bit, just a little bit. All right, good. So on the far left, obviously, we can see up top, we see the year 2024. It talks about sunrise, sunset. So this is a real easy chart. We're not going to spend a lot of time on this one. On the first It's 7:03 a.m. That's the sunrise, right? The sunset is at 4:35 p.m. It's in December, the first day, right? So we look at 9 hours, 9 hours, 32 minutes, 15 seconds, and it's a minus 1 minute and 14 seconds differential. Now, of course, I'm not going to go all the way down the line, 2, 3, 4, 5, or whatever, but let's take a look at 2 real quick. The sun rises now, what? It rises at 7:04, so it's later than what it was on the first. It sets at 4:35, same time, no difference. 9:31, 9 hours, 31 minutes, and 4 seconds. It is a minus 1 minute and 10 seconds. Okay, so let's go down real quick to 20, the 20th. Now the sun is rising at 7:18 a.m. It's a lot more than 7:03. And instead of it setting at 4:35, it's setting at 4:38. Now we're looking at 9 hours and 19 minutes and 59 seconds, almost 9 hours and 8 minutes. And it's a minus 4 second differential from the day before. And it's a minute and 10 second differential from the first. So there was only a move on the first, a loss of 4 minutes from the sun setting. So it was later. It gets late. So in other words, what it's doing is showing you that later and later and later that the sun is, rising, and it's setting later as time goes on. What's highlighted here is the 21st. Remember, the sun is leaving from the summer solstice. It's going to the autumnal autumn equinox. It's losing light. We're losing light. Like they like to say to shine. So we're losing light. And then when we get to the 21st, the 22nd, and the 23rd, it stands still. Well, apparently it stands still. It's an apparent death, right? It's the death of the sun. Then we get to the resurrection. It's the same thing. We're talking about the death of the sun and then the resurrection of the sun. Right? So we start to lose light. And then when we get to the 21st, 22nd, and 23rd, it stays. It's apparent death. It freezes. Time freezes, right? And then on the 24th and the 25th, it starts moving in, all right? And, then it's the resurrection. We're getting more light. So that's pretty much what the sunrise and sunset chart is talking about. Gaining or losing and gaining. Okay. Again, the summer solstice and the winter solstice. All right. All right. So let's go ahead now and move to the next chart. All right. Now, pretty much the same refrain. It's the sunrise and sunset. But now we're talking about, we're really just moving into January. This is the beginning of the year 24 January. It came out of December the 20. What was it? The 24th, let's say, and then down to the 31st. All right, so we didn't go all the way down to the end, to the bottom in December to look at it. But again, what we're taking a look at, we've come out of the 24th. That was the death, or the apparent death, what it seemed like. We started on the 25th with the resurrection or the rising of the sun. So now what we're taking a look at is we're gaining, but like if we take a look at we'll just jump down to the yellow, the highlighted area. 7:21 a.m. rise. The sun sets at 7:58. Obviously, last time we had a sunset in December, it was when we were in the highlighted area, it was like 4:30 something p.m. All right. So here, 9 hours, 37 minutes, and 7 seconds. It's a plus 1 minute and 22 seconds. We go all the way across to the astronomical twilight. At twilight, the sun is showing, where you see the sun, you see orange and all of these beautiful colors or whatever the case it is. You see that at 5:45, and then it ends at 6:33. The nautical twilight starts at 10:17 a.m. and then at 6 p.m. Right? Civil twilight, just different time. So where you are, 6:51 a.m. and then 5:03 p.m. And then of course your solar noon, on the 1st of January at 12:04 p.m. and you have, we just keep on gaining a minute at a time, or 2 minutes, and then what ends up happening is your noon is 12:09, 12:11, things of that nature. So that is looking at, or going to the next year, January, as we're gaining your life. Okay. So let's go into the next slide. All right. Now we get into the summer solstice here. Okay. Now we're looking at June 2025. And again, remember, we are at the highest inclination of the sun. So that means we're gaining. We've been gaining since the 25th of December. Now we're in June. We know when we get to June the 21st, we're at the highest inclination. Okay? And something real interesting happened after June the 21st. But before we get there, let's look at the first. Open this up one more time. Or make it bigger. All right. So 5:33 a.m., June the 1st. Come back down for me. I'm going to see June the 1st. June the 1st. 5:33 a.m. sunrise, 8:23 p.m. sunset. The length is 14 hours, 29 minutes, 30 seconds. It's a plus 1 minute and 8 seconds from the 31st of December. Now, just looking at the second, 5:33 8:33 a.m., 8:04 p.m. That's the sunset, sunrise 5:33. We have 14 hours, 50 minutes, and 39 seconds. Get the math on that. It's a minute and 5 seconds. So that's the difference. We're gaining, right? But there's a problem. We're in the plus. But from the first going to the 21st, we're still in the plus sector, but we're losing light. Because now, instead of starting at 5:32 sunrise, we start at 5:32 sunrise. And instead of actually, we keep the same sunset, but the sunrise changes. What also changes is the time frame, or the amount of time. So we lose just 1 second. But now, when we get to the 22nd of June and we start moving into the fall, we're losing. We're losing, all right? And we're slowly losing a little bit of time out in June, but now, instead of us having a plus, we look at minus. So if you want a number line, that would show a larger gap as far as the amount of time we're losing. Okay. So let's now move to the next slide. All right. And in July, for the most part, we passed June, so what actually happened here, and I'm not going to make this point, we're going to move off this in about 5 seconds. We're losing more. If you see up top, July 1st, we lost, 35 seconds. All right, when we get down to the 13th of July, we've lost a minute and 14 seconds. So if we just keep on increasing, going through the month of July, then we're losing 4 times. We're just losing time. So again, what's happening is the sun is moving from the summer solstice to the vernal equinox, and then from the vernal equinox to the winter solstice. So we're losing.
Excellent, brother. Excellent. This is great, man. This is how, so they can see it for them. They don't have to say El Kanah said, El Kanah said, El Kanah said. They're seeing it for themselves.
Right. And again, we look at the length of the day. Not so much the day length. The day is not getting longer, it's getting shorter. And we're seeing it through sunrise and sunset, day by day by day. This is how you read a sunset chart and sunrise chart, sunrise sunset chart. And again, this is what our ancestors do. Why are we doing this? Because we're looking at what our ancestors looked at and what they used in order to divide the time and the days and understanding, when to plant and forming clocks and how the clock move on Greenwich time and all of this other stuff. So Greenwich Mountain Time and all this other stuff. So this is how it was done, or this is how it was done in order to, by looking at it. This was looking at the constellations and the sun in order for us to determine how time is moving. And then that's how we set the clock. That's how we created that nature. No. So, because it wasn't always didn't always have batteries. So there was other electronical things that were actually going on, and magnets that were actually being used. You know, so all right. Well, let's go ahead and move on. Oh man. Okay. All right, y'all. Don't kill me. So we got a lot more, but I'm gonna try and move through quickly as possible, slowly as possible. So let's take a look at Board Saint Maurice, Amor, as we can see, and this is a high position that he's in, with the sword and flag and his outfit, you know. But let's take a look at this this flag here, or banner, or flag. So we have Saint Maurice. All right. We have a star on the other side. We have tree, a wintergreen tree. All right. And we have this cross in the middle. All right. So what we're taking a look at here, again, looking at the 4 seasons, we're looking at, depending on, well, no, let me not go there. Depending on, no, I'm not even going to say that. So we have the 4 seasons. That's what this is talking about, from left to across. This is tying the astronomy in the culture, the Moorish culture. All right? And I'm not going to let the cat out of the bag just yet, but we're going to go to the next slide, and we're going to try and determine who is this Saint Maurice. Now, this is the same guy that we just saw in the last picture. All right? Now we see him as a soldier instead of an aristocrat. I'm not even to read what's on that card, but Saint Maurice, all right, martyr of the 7th Legion, patron saint of soldiers, and the military feast day. All right, and this is a Saint Maurice prayer, or prayer. Called him Saint Maurice. So let's go ahead and let's move. The thing that I wanted us to actually take a look at is, this is Moorish culture. Well, all throughout, but now we see pictures. We're looking at the first picture was an aristocrat. Now we're looking at soldier. So this is proof that throughout the century, we have had, this is proof of Moorish existence. All right. So let's go ahead and go to the next slide. That's the patron saint, Saint Maurice again. And in this particular picture, he is giving, or he's having counsel with like a king or something of that nature. Okay.
Oh.
All right, let's move on.
Yeah, Pope.
Yes, Pope.
A Pope.
Mm-hmm.
Pope. Okay, yeah, Pope. Yeah, that's the clergy. Yeah. Yep. That's the Pope crown. Well, the popes were like, you know, the popes were like kings. They had both the power of the king and the clergy. So, and here's Saint Maurice again. another prayer. Okay. Let's move on. And we see him again. All right. And I think on the next slide, it's going to tell us where we got the. Well, let's move on. Okay, fine. So, all right. Now let's see what has happened here. Well, I guess Abdullah, we did have to talk about this. So we see a poke here. What we see with a red and kind of gold cape or coat with a white spot. What it is when we look at go back to Saint Maurice is who we've imaged or who has been called out of being Santa Claus, or is Saint Maurice? Santa Claus is where Saint Maurice idea came from. Now we have Santa Claus, right? We took the Moorish connection and Saint Maurice out of it, and we have Saint Nick. And, at least they left Saint in there, but they left Maurice out, and they changed his color or changed his complexion. All right, his pigmentation. All right, let's go ahead and move to the next slides. Again, it's just I put that in there just to show that they changed Saint Maurice to whoever this character is. Right. All right, let's move on. And then even more so, this is one that we know for all. So they took the saint part out. They took the clergy. They took the power out of it. So then now all we have is and then they changed the color, right? Of the, I'm not talking about his pigmentation. They changed that too, but they changed his dress code. They changed his Moorish attire. They changed everything. So they turned it around. But there's a reason why it was. There's a reason why we have the red and white right now. Let's go to the next slide so we can see why is it red and white. This right here is a monk. And as you can see, it's red and white attire. He has red and white attire. All right. Let's go to the next slide. Now here's something that's real interesting. Real interesting. Ancient picture of a York kind of a hut or tent, but it's called the York. It has a flag. And look at the color of the flag. All right. And then the York itself is white, but the flag is red. Again, you're looking at Moorish culture. And it's a hidden meaning because you can't spell it out and let you know the information. You just have to know that it's a Moorish flag or a Moorish insignia. But all you look at is something red and then white, and let's go ahead and call it Christmas. All right, let's go ahead and let's move on. And in the inside, if you can really see, you still see the theme of two different things going on. You have the gold and the red, which you have, that's a Moorish insignia or regalia. And then you have this white kind of footrest or whatever it is. All right. So in the inside, true of this view, the true colors are being represented. But from the outside, you see white, then you see a red. And it's not true for every New York. So, but this imagery that I wanted to pick out so that I can make a point. All right, let's move on to the next one. Again, we have a monk here, and notice where it is, these would look like strawberries. The strawberries are red, and they have the white coloration on them or whatever. But actually, these are mushrooms that the monks use in rituals and ceremonies. And notice how they are in tune with nature. Because these red mushrooms, specifically red mushrooms with the white tops, this is what the monk had. A red outfit with white polka dots. All right, let's move on. And again, same thing, outfit, in holding up the mushroom, having the extra mushroom, okay? A red mushroom with the white, dots, white particles in it, right? And this is dealing with these particular type of mushroom, you're able to, with mushrooms in general, you're able to take care of a lot of different diseases. Okay. And there's some hallucination sometimes with some mushroom, depending on the power of that mushroom. Right? But anyway, red and white, again, this is where we get Christmas. This is the theme of Christmas, the red and white. It comes from Moorish culture. It comes from, and I say the Moorish culture because this is talking about the rituals and ceremonies that monks use. These particular monks, it's a red mushroom with the white dots or the white particles, whatever the case it is. So that's the theme of these particular mushrooms and these monks wearing this particular outfit. So when you take the culture aspect out of it, then it just becomes red and white, and it has no meaning. But when you put the culture in it, now you can see red and white. You're like, oh, that's what it's about. And guess what? We're a couple of days away, the 22nd, the 3rd, 4th, and the 5th. We're a couple of days away from the sun dying. We're a couple of days away from red and white. Well, we're doing the red and white now anyway. That's Christmas. Everybody talking about it.
Yeah, that was yesterday. That was yesterday. The sun dying.
The sun died. Yeah.
The sun died yesterday.
Yeah. But the sun is still in its day. It died on the 21st, but it's
still,
at
those point. Yeah, the hovering. It's hovering. Yeah, but it died yesterday.
It's still in the apparent death right now. So it died, but it's still in the apparent death.
It's in the tomb. It's in the tomb.
Yeah, it's in the tomb. That's right.
Yeah, for 3 years.
All right. So let's move on to the next slide. And again, this does this. These are the fly agaric mushrooms. Okay? In the old world, the psychoactive fly agaric mushroom has been closely associated with the Northern European Asiatic shamans and their ritual. All right. So I just wanted us to just know what the name of that was. We're not getting into no long, because each one of these points could be a whole lecture by themselves. But I just wanted to bring some points and concepts to mind. Again, the red and the white mushroom. And like I said, the mushrooms have these properties of psychoactive. I didn't use the word psychoactive. I just said it was, I forgot exactly what I said, but it puts you in let's just use psychoactive. That's a good word. And you can see how big these mushrooms grow. They can grow as big as your hand, you know, a large size hand. Because that's a pretty big mushroom. Okay. All right. So let's move on to the last. I don't know if it's the last slide or not, but let's move on to the next one. Oh, that was it.
You want to play the video?
Oh, yeah. Let's play the video. Let's play the video. All right, this is it. Now,
When there is a family. Your head will go around. Three. This is Russell, as you see. A lot of Russell and butter mushrooms. I call them noble lexinums. They grow under aspens.
all right,
You always eat odd numbers. 1, 3, 5.
No, not one number. People, how these, what the mushrooms are, and what the psychoactive, in other words, they get you high. But it's not for that. It's not selling on the street, you know, trying to like marijuana, but it's in the ritual of them getting into deep concentration and focus. So, you know, that's the purpose of the flight mushroom. Okay. Yeah. I believe, yeah, these are just some of the more, it's like a strawberry, right?
Mm-hmm.
It's red and white. And actually, it's red and white, it's red and gold. Right? So yeah, that's a red and white one. But the other one's the red and gold, more so towards traditional, right? Traditional ancient Moorish look of the gold and red. In a lot of cultures, the Asian cultures, African cultures, all of these cultures have that red and outfit with gold embroidery, and sometimes white embroidery too. Mostly gold, because those are ancient colors that are always used together. So yeah, these are just the modern midwinter and Christmas celebration, and then these are just different questions. We don't have time to get into those right now, but there's the myth saying that behind every myth lies a wee bit of truth, and what that truth is the fact that you have looking at Santa Claus, looking at the red and white, but there's a reason behind that. That color of red and white talks about when you look at the red and gold, before you look at red and white, look at Moorish attire, royal Moorish attire. Okay, when you look at the red and white, looking at a dark mushroom used in rituals for deep concentration, focus, and then it's the shaman outfit, as well. So when you take the meaning out of a story, then it loses the significance. Right.
The candy cane, the red, white candy cane.
Oh no, yeah, the red. That's right. And that's all. That's right. The red and white candy cane. Right. That's where we often see it right again. Being used during Christmas time, peppermint, red and white. But again, when you remove the storyline, when you remove the actual, you don't know about Saint Maurice, you don't know about the shaman, you don't know about the fly dark mushroom, then you don't have that meat. You just, okay, yeah, red and white. And then you remove the culture from it. You change the pigmentation, you change the more the Albion in, and now what actually is, you're like, okay, well, everything has been replaced. The meaning has replaced the culture, all of it. So you just aimlessly looking. So these are misconceptions that we didn't even know that we had. I'm talking about the masses. All right. So, Israel, is that it?
Nah.
Oh, dang. What we got
Yeah,
next?
we'll go. Since we started off, because we can't go too much far. We'll at least at the end by 10 after. Let's try we'll end at 10 after.
Let me run through this. I'm just gonna take bits and pieces here because we all know this is shaman. We know the shaman has the red and white, right? So that's what we're looking at. Whiteness. I mean, that's right. Make this bigger for me. Thank you. A little bit, maybe. Okay. All right. Yeah. This is crucial. This is where we're gonna end. Good look. Abdullah. So in the days leading up to the winter solstice, the fly, a dark mushroom, appears under the trees. So they do come out. Mostly firs and spruces. The fly dark mushroom's cap is dark green to reddish orange, with creamy white small patches dotting the cap in an irregular pattern. In Central Asia, shamans wore special garments to collect the fly ajar mushroom. Their coats and pants were red, with the collar and cuff trimmed with white fur, topped off with black boots. Does that look familiar? Does that sound familiar? Okay. The shaman collected the fly ajar mushrooms in a special sack. After collecting the mushrooms, so the sack was a red sack. Okay, sounds familiar? Sounds like anything we know about. The shaman would return to his village and enter New York, a portable tent dwelling. Remember, that's what we took a look at, New York, through the smoke hole of the roof. Does that sound familiar? They will enter through the roof. This is Christmas, y'all. During the ceremonial ritual, the shaman would consume and share the sacred mushroom with the participant. The smoke hole was a gateway or portal into the spiritual world, where the people would experience many things. Remember, this mushroom got you in a euphoric type of it kind of in a state of hallucination. So among the Sami Laplander people, the hallucinations associated with ingesting of the fly ajar gave the sensation of flying in a spiritual plane. Sound familiar? Pulled by reindeer or off horses, i.e., Kanah and his slave journeying out into the night to give gifts. This is where we get the Santa Claus. This is where we get the image from. Changing St. Maurice to Albion, wearing the red and white suit, entering into the chimney. This is where all this is coming from. Let's just take a quick peek. And I didn't know the slide. I didn't know we had these many, and I didn't mean to spend as much time as I did. Can you widen that out? I think this will be it for us. Make it a little bigger.
That's really it. That's all I can do for real.
That's big as it got. All right. Can you make that out for me?
You want me to read it?
Yeah.
Elders, mycology of hallucinogenic mushrooms on Christmas. The story of Santa Claus is not the creation of Coca-Cola, nor St. Nicholas, or a children's story. It exists because of a small living being with great powers, the Amanita muscaria mushroom. December 20, 2020, Guliana Fursi Fungi Steph, founding director. Robert Gordon Wasson, an ethnomycologist and anthropologist, John A. Rush have investigated fungi, the religious and ritualistic perspective, and also their psychotropic properties. In their research, both came to the conclusion that the Amanita muscaria mushroom is closely related to the Christmas imaginary. Hundreds of years ago, it was found at the winter solstice ceremony of the indigenous peoples of the North Pole, especially the Koryaks of Siberia and the Kamchadals, had similar traditions to the ones of the last century's Christmas Eve. In the ancestral communities, of the Arctic, the winter solstice, which occurs on December 21st, was a ceremonial and festive date. Rituals were conducted that were guided by shamans who collected the Amanita muscaria mushrooms, also called fly agaric, which has powerful hallucinogenic properties. Amanita muscaria, Guliana Fursi, Emmanuel Salzman. Amanita muscaria is striking and characteristic in appearance. With its red hat with white dots, it grew on the ground near trees such as birch and pine. The latter, for the indigenous people of the North, are trees of life, a name that related to their great height. Therefore, the place where the fly agaric mushroom grew was a place of particular value.
I appreciate it, Israel.
Indeed.
The entire this entire lecture was a presentation, was a explanation of what we traditionally look at or call Christmas, and it's an explanation from the Moorish culture, the astronomical value and mathematical value, and its relationship to masonry. So I thank you guys for your attention. Sorry for I got to figure this technology thing out. I don't want to say that I hate it. I'm not going to say I like it either. But I thank you guys, family, for listening. I thank you, Hank, for having me. Thank you, Abdullah, for signing in. I thank you, Yisrael, for moving through and helping me out. So that I yield the floor, and I say Islam.
All right, till next week. My series and I will be back on track with our Moorish Connection to Masonry series. All right, so once again, my website, moorsandmasonry.org. Anyone who's interested in getting my books. Thank you, Hank. All right. Thank you, Israel, for co-piloting. I greatly appreciate you. All right. All right, peace, everyone. Merry Christmas. Ho, ho, ho. The birth of Jesus. Jesus' birthday. Baby Jesus. All right. The resurrection of the sun. More light.
More light.
For those, I'm out.